Hello everyone, today we're going to be solving AQA GCSE Chemistry Foundation Tier Paper 2. Today we're solving June 2022. This is the part 2 of the question paper where we're going to be solving from question number 6 to question number 10. A student investigated the rate of reaction between sodium thiosulfate solution and hydrochloric acid. Figure 7 shows the apparatus that are used. We used a light source and a light sensor and the beaker with the reaction mixture. When hydrochloric acid is added to sodium thiosulfate solution, the mixture gradually becomes cloudy. A smaller percentage of light from the light source reaches the light sensor as the mixture becomes more cloudy. This is the method used. Measure 50 cm cube of sodium thiosulfate solution into the beaker. Add 10 cm cube of hydrochloric acid to the sodium thiosulfate solution. Immediately start a timer. Record the percentage of light from the light source that reaches the light sensor every 20 seconds for 120 seconds. When sodium thiosulfate is reacted with hydrochloric acid, it produces sodium chloride, water, sulfur dioxide, and sulfur. It is the sulfur that causes the solution to go cloudy. So there are two sodiums, so it's going to produce 2 sodium chloride. The mixture becomes cloudy because the sulfur produced is a solid. What is the state symbol for a solid? So solid has a state symbol of S, liquid is L, gas is G, and aqueous is AQ. The student monitored the cloudiness of the reaction mixture using a light sensor. What other piece of equipment could be used to monitor the cloudiness of the reaction mixture? Typically, we can use a paper that has a cross in it. All right, so a cross on a piece of paper can also be used along with the timer. Percentage of light from the light source reaching the light sensor slowly decreases as the time passes, and then it levels off. What happened to the rate of reaction between 40 and 60 seconds? So between 40 and 60 seconds, we can see the rate is gradually decreasing. All right, the rate of reaction gradually decreases. So this one is the answer. The student stopped taking measurements after 120 seconds because the percentage of light reaching the sensor stayed constant. Why did the percentage of light reaching the sensor stay constant? So this indicates that no more new sulfur are being produced and the reaction has stopped. We can say one of the reactant was used up. That means the reaction has stopped. The student repeated the experiment using sodium thiosulfate solution of higher concentration. How would the line of the best fit for sodium thiosulfate solution of a higher concentration compare with the line of the best fit of figure 8? Typically, when we are going to use a higher concentration, we're going to get a faster reaction. So initially, the line of best fit would be less steep. No, it's going to be more steep, not same steepness. It would be initially the line of best fit would be steeper. Exactly correct. The student then investigated the effect of changing the temperature on the rate of reaction. The student used sodium thiosulfate solution and hydrochloric acid, which has been kept in an ice bath. Which are the two effects of using reactants kept in an ice bath rather than at room temperature? When we keep something at an ice bath, it has a lower temperature. That means it's going to have less amount of energy. So fewer reactant particles will have the energy to cross the activation energy. So fewer reactant particles have the energy to cross activation energy. The next option, reactant particles collide more frequently. No, they're not moving as fast, so they can't collide more frequently. Reactant particles have more energy. They're going to have less energy because they are at low temperature. Reactant particles move more slowly. This is correct. So these 2 points are going to be correct. And the last one is there are fewer reactant particles in the same volume. Temperature does not affect the number of reactant particles. The question is about fertilizer. Ammonium nitrate is a fertilizer containing nitrogen. Ammonium nitrate is produced by reacting ammonia with nitric acid because it says nitrate. Ammonium nitrate fertilizer is sold in 600 kilogram bags. A farmer spread 40 kilograms of ammonium nitrate fertilizer on land with an area of 800,000 meters square. Calculate the mass of ammonium sulfate fertilizer spread per meter square of land. We have to find it in kilogram per meter square. So we will divide the 600 kilogram. We'll multiply the 600 into 40 to find out the amount in kilograms. And whatever the amount in kilograms we're going to get, we're going to divide it by, say, 800,000. A scientist works for a company which makes ammonium nitrate fertilizers. Scientists investigate the effect of different fertilizers on crop growth. Scientists conclude that ammonium nitrate fertilizer improves crop growth more than other fertilizers. Suggest one reason why this conclusion might not be valid. In order for crops to grow, plants require NPK fertilizer. All right. And since potassium is absent in this particular fertilizer, so we can also say because the scientist is working for a particular company, all right, the scientist review might be biased. Or we can say there was no peer review. Different fertilizer containing nitrogen has the formula K2NH4PO4. How many atoms of nitrogen are in the formula? You can say only one atom. Nitrogen and potassium in the fertilizer K2NH4PO4 are important for good crop growth. Which other element in fertilizer K2NH4PO4 is important for crop growth? So hydrogen and oxygen, all right, this is always available to water, is the phosphorus. Some fertilizers are mixtures of different compounds in fixed proportion. What name is given to a mixture of compound in fixed proportion? A fixed proportion is always known as formulation. This question is about copper wire and copper compounds. Copper is used to make electrical wires. Figure 9 shows how copper electrical wire is insulated using an additional polymer called polybutene. The addition polymer polybutene has the displayed formula shown in this diagram. Polybutene is produced from the monomer butene. Complete figure 10 shows the displayed formula of butene. Now, in order to make a monomer from a polymer, we're going to take away the two hands and we're going to put a double bond in between them. So we're going to put double bond between the carbon and re-establish the bonds. Copper can be obtained by recycling scrap copper wire. Suggest why polybutene insulation must be removed from the scrap wire before the copper is recycled. Otherwise, if we melt the copper, all right, along with the polybutene insulation, all right, there would be a mixture that would be produced and it would be impure. It would not produce pure copper. And the insulation material would burn during the recycling process and may produce harmful toxic fumes. Describe how scrap copper wire can be recycled to make new copper wire, copper water pipes. So the wire will be heated until the copper melts and all of them, turn into liquid molten metal. And then they can be put into a recast or reformed into pipes. Suggest 2 reasons why recycling scrap copper is more suitable than extracting copper from copper ores. Recycling scrap copper uses less energy. It conserves copper ore. As a result, it also produces less waste. All right. And, the more we're going to mine copper, it's going to lead to environmental impact. All right. Which are, common to copper extraction. All right. Copper ore extraction. Copper sulfate is a compound of copper. Copper sulfate solution contains copper 2 plus ions and sulfate ions. A solution can be added to copper sulfate solution to show the presence of copper 2 plus ions. Name the solution. Give the result of the test. So, in order to show that the copper is copper 2 plus, we can add sodium hydroxide solution. And sodium hydroxide solution will cause the copper 2 plus ion to produce a blue precipitate. Describe one test to show the presence of sulfate ions. So to test for sulfate ions, we can use barium chloride along with nitric acid. We can use barium chloride along with hydrochloric acid. A white precipitate will indicate positive test for presence for sulfate. A student investigated the change in mass when hydrated cobalt chloride was heated. Hydrated cobalt chloride produces anhydrous cobalt chloride and gives off water. 2 grams of hydrated cobalt chloride was put into an empty test tube. Measure the mass of test tube and contents. Heat the test tube and contents gently for 30 seconds. Allow the test tube and contents to cool. Measure the mass of the test tube and contents. Repeat steps 3 to 5 until the mass of the test tube and contents does not change anymore. So the results are given here. Okay, we can see from 90 to 120, the mass did not change. Determine the mass of empty test tube. 2.65 was the mass of the test tube plus the hydrated cobalt chloride. So we will subtract 2 grams from there. So the mass will be 24.5. Explain why the mass of the test tube and the contents decreased. So obviously when hydrated cobalt chloride was heated, water vapor was produced and the water vapor could escape from the test tube, which decreased the mass. Suggest why the test tube and the contents were heated until the mass did not change. We reheat the content again and again and measure the mass to ensure that there is no more water of hydration left within that particular salt. So we can say, so that the reaction was complete. Energy is taken in from surroundings when hydrated cobalt chloride is heated. When 238 grams of hydrated cobalt chloride is heated until the mass does not change, 88.1 kilojoules of energy is taken in. The student heated 2 grams of hydrated cobalt chloride until the mass did not change. Calculate the energy taken in during this reaction. Give your answer to 3 significant figures. So we already get the information that 238 grams of hydrated cobalt chloride requires 88.1 kilojoule of energy. So for 2 grams, so energy needed for 2 grams will be 2 divided by 238, and then we're going to multiply it with 88.1, and thereby we'll get the answer in kilojoules. Then we're going to turn it into 3 significant figures. What type of reaction takes place when hydrated cobalt chloride is heated? Well, we are heating and this particular reactants are absorbing the heat, so this is an endothermic process. This question is about life cycle assessment (LCAs). Milk bottles can be made from glass and from a polymer. So glass is made from limestone sand, sodium carbonate. It requires 6750 kilojoules of energy input, and energy needed to manufacture the bottle 750. Mass of the bottle is 200, and we can use it 25 times recycled to make a different glass product. We are able to do that. When in the case for polymer, we use crude oil. We use 1710 in material energy, 90 in making the bottle. 20 times we can use the same bottle. Sorry, the mass of the bottle is 20 grams. We can use the bottle only one time. Recycle to make different polymer products. We can do that. Evaluate the use of glass for milk bottles compared to the use of polymer for milk bottles. Use features of life cycle assessment in your answer. In a question like this, we have to take the information from here. So how we are going to go about this? First of all, we're going to talk about raw material. Since we are asked to evaluate the use of glass for milk bottles, compare it with polymer for milk bottles. So we can give the point like this. For the raw material, crude oil is a finite resource, all right? And mining it pollutes the environment. Glass uses more energy as a raw material input, okay? Then for manufacturing, glass uses more energy to make per bottle. Glass is heavier, so it takes more energy to transport. And in terms of operation, glass bottles are reusable, all right? And reuse of glass will conserve natural resources, all right? However, energy will be consumed during their washing cycle. In terms of disposal, both glass and polymer bottles can be recycled. Recycling polymer conserves the finite resource where it came from, which is the crude oil, and recycling glass and polymer uses less energy than making new glass and polymer. Both method reduces the use of landfill. We can also include that energy needed may be derived from fossil fuels. All right. So in the case for glass manufacture, the energy needed for making fossil fuel, the energy needed for making the glass bottle is 3 times higher than that. It's almost 4 times higher. Is almost 4 times higher than that for the glass bottle than the polymer bottle manufacture. So use of fossil fuel causes pollution. All right, in general. So glass, even though it may look greener, all right, might not be a green solution after all. Milk is also sold in cardboard cartons. A carton is made using 40 cm³ of cardboard. The density of the cardboard is 0.4 gram per cm. Calculate the mass of the carton. Use the equation density mass divided by volume. We know that mass is equals to density times volume. So mass 0.4 gram per cm³ multiplied by 40 is equals to 16 grams, or 16 grams of material is needed. So guys, we are done with this particular question paper. Thank you for joining this particular video. And guys, best of luck for your exam. See you in the next video. Bye-bye.